Today, I'm excited to introduce our project, the AI Assistant Ballot Translator. Let's look at a specific ballot measure here. Shall the Missouri Constitution be amended to make something like that? So as voters, it's natural to ask, what does this mean for me? How should I decide whether to vote yes or no? Many people face the same questions when reading the complex ballot language. So understanding a ballot measure often requires researching supporters and opponents, their arguments, and the findings behind each side. Tasks that can be time-consuming and confusing. So this is where our tool comes in. Our aim is to help voters gain a clear understanding of a ballot measures intent, implications, and context, so they can make informed decisions based on their own values and priorities, quickly and confidently. To achieve this, we first get a conclusion here. Okay, let's build an AI assistant ballot translator. So move on this, we first developed a team alignment map here. We identified the problems here, the voters' need and expectations.
Thank you, Shiling. And for my part, I will go over the joint resources. And some of the resources we have are the ballot data is provided by Ballotpedia, which has historical and current ballot measures that are seen in the voting booths. And the large language model we're thinking about using is either IBM Watson X AI or Cohere R Plus model. And for web searching, we are planning to use Google SERP API. And finally, for embedding some of the text ballots that we see, we are going to use the All-Mini L6 version 2 sentence transformer. And for displaying our website and taking in inputs and displaying out outputs, we are going to use Gradiote. And some of the risks that we anticipate is the ability to scrape data, issues with API accessibility, and then also if we are able to coordinate our outputs with the user interface.
Building on this alignment, our project has three main goals. The first is to provide voters with a one-stop explanation, including context, background research, and neutral summaries of arguments for and against the measure. The second is deliver results within 5 minutes, enabling voters to make informed decisions quickly. The last one is provide relevant and unbiased information by combining internet search with advanced large language model, ensuring voters receive a clear and balanced view. Through this approach, we hope to make the voting process simpler, faster, and more informed, allowing voters to confidently understand and engage with ballot measures.
This is our workflow for how our model works. So first, we extract all the keywords from the TF-IDF spacing model and extract the top 5 most important words from the ballot. Using those top 5 words, we are going to input those into Google search using the API and search based on those keywords. And then we fetch all the web sources that Google has procured for us and compare them to the original ballot measure to see how similar each data source is to the source that was fetched. So the more similar they are, the higher the rank they would get. So the most relevant web source to the ballot measure should be ranked very high, and then the second most relevant should be ranked the second highest, and so on and so forth. And once we know the web sources that are most similar, we scrape more content from those web sources if we are able to fetch more context and details and information from the website. And then we feed that context into the AI and prompt the LLM to intelligently summarize that scraped content and maybe make it more relevant to the ballot measure that the voter is looking at. And then we also additionally prompt the LLM and ask it, is there any biases or leanings from the ballot proposer? And where does the funding comes from, if we can find it from the web source context? And finally, we display the summarized output into a website. And we will show all this process in our demo, but this is a workflow of what is happening in the background.
This is what our Gradio user interface looks like, and you can access it from a website. And here I am selecting one of the example ballot measures from 2024. I click it and it should automatically populate the input, and you can change it to whichever ballot you are interested in. And in the example here, we can see this one is about this particular ballot measure, and I can click Learn More, and it should be able to help make a summary in a few seconds. And here you see the LLM generated summary from web search context, and then if you want it to also elaborate more on the ballot measure, what it means, and then here you can see again this is a summary, and this is the elaboration. And finally, we also have a full JSON response that you can copy and paste and store in your own file.
And thank you, IBM SkillsBuild, for bringing us together. This is our team members. We have Shiling, Levi, me, Wen-Hsin, Maya, and Sam Spill. And we all come from Mizzou, and these are our colleges. And thank you, IBM, again, for providing us with Watson X AI and plenty of educational resources so that we can explore and learn about how LLMs and AI work